Today we're going to consider this additional problem for Gunning's Introduction to Analysis, which reads as follows. Show that if A is a real n by n matrix such that a squared equals 0, then the rank of A is less than or equal to n over 2. Take a couple seconds to try this out for yourself, then we'll do some hints, then we'll get on with the proof. Alrighty then, for some hints, we'll recall that if we want to find the rank of a matrix, it's probably going to be useful to use the rank nullity theorem in some way. You should consider some ideas about what a squared equals 0 really means. Alright, let's continue. So, a squared equals 0, the piece of information that's going to tell us is that this implies that the image of A is a subset of the kernel of A. And the way we show that is, like, suppose this weren't true. Suppose there was some v in the image of A that was not in the kernel of A. Then, because it's in the image, there exists some pre-image vector such that A sends that pre-image vector to v. And then a squared on that v is going to be some other vector, w, where we get a squared v equals w, where w is non-zero since we had that this v was not in the kernel of A. Well, now we've shown we have a squared something to not 0, therefore a squared could not be the 0 vector, therefore our assumption that the image of A was not in the kernel of A is false, so we have this statement. This implies that the dimension, I'm going to use just big D for now, of the image of A is less than or equal to the dimension of the kernel of A. And this just happens from the properties of subspaces. Now we'll apply the rank nullity theorem, which says that the dimension of the image of A plus the dimension of the kernel of A is equal to n. How does this help us? Well, since we have the dimension of the image of A is less than or equal to the dimension of the kernel of A, this implies that twice the dimension of the kernel of A is actually going to be bigger than n, which implies that that the dimension of the kernel of A is going to be greater than or equal to n over 2. And I can plug this back into the rank nullity theorem, and we get that this term on the left-hand side is going to be bigger than or equal to what happens if we substitute this in. So in particular, we get n is greater than or equal to n over 2 plus dimension of the image of A, and then we simply subtract this n over 2, and we get n over 2 is less than is greater than or equal to the dimension of the image of A. And then finally we recall that this is just the rank of A. So we get that the rank of A is less than or equal to n over 2. And we're done. Thank you for watching.